In this video, we're gonna go over the solutions to our practice on Venn diagrams and contingency tables. One thing to keep in mind as we work through these problems, there are different strategies you can use to approach Venn diagrams. And so I'm just giving you some, but you might find another method more effective for you. They're sort of like logic puzzles, and everyone might approach them a little differently, and it doesn't make your strategy wrong. But I will sort of go through my thinking as I approach these problems. All right, well, number one isn't really about making a Venn diagram, it's about reading a Venn diagram. So we have here a silly Venn diagram, and I like to make them a little on the silly side sometimes. And so we have a number of deers surveyed, and we have a group that enjoys running. So I'm gonna just make that circle, it's the R circle. So this circle I'm highlighting in red are all the deers who like running. I mean, not red, green. And then, let's do red this time. N is the deers who enjoy eating. And so that would be this circle right here. And all the numbers within that represent the deers that enjoy eating. And then last but not least, we can do some blue. And these are the ones who enjoy staring into headlights. Just to give you a sense. And the number outside then would be like the none group. All right, so in the very first question, we are asked, how many enjoy running or staring into headlights? So a key thing to keep in mind when you're looking at an or relationship, basically it's anyone who said they liked running, anyone who said they liked staring in headlights, which means it could be people who only enjoy running, it could be people who only enjoy staring into headlights, or it could be people who do both, and it could be people who also enjoy the eating, but it's just not specified. So when you do ors, it's actually everything in those two circles. So we're looking at the enjoy running circle, and I'm just going to highlight this in yellow for now. And the staring into headlight circle. So everything I have highlighted in yellow right now, we would count that in this number. And so to figure this out, we would add up all those values. So it's like 3 plus 8 plus 13 plus 21. Those are all the ones in the running circles. And then we also have that 25 and the 18 that are in the staring into headlights. And so if you added up all those numbers, we would end up with 88 deers. And so ors tend to be large values because we have so many, it's so open-ended. All right, so the next one we're going to look at, and I'm going to try and erase my highlights, okay, is an and relationship. So here we're told, I'm going to give it a different color this time, nibbling and running. So this means that both need to be true. So we're looking for something where both of them are true. And so we're focused on the overlap between running and nibbling, which would be this part right here. And yes, it does include the part that also shares with staring into headlights, but it's purely the overlap. And so we'd have 8 plus 21, which comes out to 29. All right, then let's move on to the next one. So the people who enjoy exactly one of these activities. So they didn't pick more than one, and so we're looking at those numbers that are on the outside, but still in a circle. So 7, 3, and 25. And if I add up all those numbers, I would get 35. Okay, the next question is saying enjoys staring into headlights, but not running. So the not running part tells me that we're gonna sort of cut that part of the circle out. So we're gonna ignore the running, but we have everything else in the staring into headlights. So I want nothing in the green circle, but everything else in the blue circle. So it'd actually be these two numbers, the 18 plus 25. And when I add those two numbers together, I would get 43. All right, last but not least, we are asked for all the number of deers who enjoy nibbling. So that's basically just everything in the nibbling circle. So there are 4 numbers we'd add up, 8, 7, 21, 18. And when you add them together, you should get 54. So just to sort of, 8 plus 7 plus 21 plus 18. Just give you a sense of what I added. So hopefully that gives you a sense of how to read Venn diagrams. We want to be sure that we can sort of pick out these numbers, because when we get to probabilities, it's going to become important that we can find the number so we can, correctly set up our probability problems. All right, so the next problem, we're actually going to do two things. We're going to make a contingency table, also known as a two-way table. So when it says make a two-way table, it's just another way of asking for a contingency table. Summarizing some results, and then we're going to make a Venn diagram, and then we're going to answer some questions. Okay, so let's set up our contingency table first. I'm going to use black to make the table. So we have runners who completed a marathon and they were given a drug test. 24 tested positive, 6 of which finished in the top 10, and 35 runners tested negative. So if I'm looking at my quantities here, one of the things is just how they finished. So it's like the top 10 and then not in the top 10. So that was one of the data sets I was given. The other is their test results. So we had positive test results versus negative test results. And then I like in my contingency table is to have the total rows. All right, so let's fill in what we know. So what we know, we're given 6 of the ones that finished in the top 10 tested positive. So that means there are 6 here in the top 10 that tested positive. 35 runners tested negative. So that's actually like a total down here. So that's the total number who tested negative. 24 who tested positive. So that would be the 24 there. And that's really all the numbers we're given. But now we can sort of go through, and I'm going to use a different color just so you can sort of see this, and we can fill in the rest. So 24 plus 35 to get our total number of runners would be 59. And then if it's top 10, I know there's 10 runners in the top 10. And if 6 tested positive, then 4 tested negative. I'm just sort of using logic. If this is 10, 10 minus 59, 59 minus 10 would get me 49 who are not in the top 10. If this is 4, 35 minus 4 is 31. And 24 minus 6 is 18. And so I sort of filled in the rest of my numbers based on what I saw. All right, so the next step, we want to make a Venn diagram. So there's many different Venn diagrams I could set up here, but if I'm thinking about probably what I care the most about in this data would be people who tested positive, and then my sort of top 10. And, finishers. So when you're looking at a two-way table, you almost want to highlight the variables you're focused on. So, one of the variables we're focused on is this top 10. The other variable we're focused on, somebody's red, come back here, is the top 10. Oops, I did that backwards. So positive and the top 10. And I highlighted it backwards here, so I'm gonna, erase and fix my highlight. So top 10, sorry about that, and positive. Now, why I highlighted here and then sort of highlighted here is basically the numbers that I highlighted are sort of where they go in the Venn diagram. So where you see the yellow and red overlap, that's the value they share in the middle. That's the 6. And then 4 is the purely in the top 10 but didn't test positive, and the 18 are the tested positive but not in the top 10. And then the number not highlighted at all, the 31, that would be on the outside. And so I can sort of use my contingency table to help me create that nice Venn diagram. All right, so what percentage of runners in the top 10 did not test positive? Okay, so we want a percentage. When we start with percentages, we want to set up a fraction first. It's a good practice. So what percentage of runners in the top 10? So we're only focused on the top 10. So this is a fraction out of 10 and did not test positive. Well, 4 of the top 10 did not test positive. And if I want to turn that into a percent, I would divide this and then times by 100. and I would come out at 40%. And how many runners total were tested? There were 59 runners. So that's a sense of how contingency tables and Venn diagrams relate. All right, we got one more problem on this side, and so we're going to do this one in this video, and then the next video we'll pick up on the next page. All right, so we have a restaurant that hired Dennis to determine what kind of appetizers customers like. He surveyed 100 people, and he got the following results. And Dennis told the restaurant that every person interviewed at least liked either fried pickles or mozzarella sticks, or both. And does this seem correct? So a great way to do this is to sort of organize my answers in a Venn diagram to determine. So if I notice, okay, so I have circle 1 and circle 2, and so we have pickles, P, and mozzarella sticks, M. 35 like both. Okay, well, 58 like fried pickles, but we already have 35. So if I take 58 minus 35, I would wind up with 23 people who like fried pickles only. Same idea with the mozzarella sticks. So 77 minus 35 would get me 42. And so let's see how many people we have. So if I take 23 plus 35 plus 42, and I add these up, 3 plus 5 is 8, plus 2 is 10, plus 20 is 30, 60, 100. So that would mean, yeah, there's 0 people on the outside. So does this result seem correct? Yes, because when we built our Venn diagram, we have 100 people inside all the circles. And that would be sort of the appropriate way to approach number 3, and I would justify it with what I see in my Venn diagram. Hopefully this video sort of helps you better understand the first 3 problems on your homework practice.